All right, so I wanted to do a little bit more on inverse functions. We didn't get this far in class last week, but this is part of 6.2. If you have the notes still, it's like the last page, an example 7, example 8. So an inverse function, we have the graph of a one-to-one function, and the graph of its inverse are symmetrical over the line y equals x. So that's kind of important to know. Remember we talked last week, and we defined kind of an inverse is when you switch the domain and the range. So the domain of the function f, remember we had these little pictures, and this was the domain of f, and this was the range. And when we had the inverse, this is f, we have our x, that one over here, right? When we have our inverse, we switch that around. And so now our domain is the range of what was our original function f, and then our range is the domain of what was our original function. All right, to find the inverse of a one-to-one function, there's 3 steps. Step 1, switch your x and your y variables. So every time you see an x, you put in a y. Every time you see a y, or remember f of x equals y. So every time you see that, you put an x. Step 2, solve for y. Step 3, and we did this last week, that's where you check to see if when you plug one function into the other, you get x. So let's do some examples. All right, example 7 from the notes last week. This is also in 6.2 of your textbook. But this example has us find the inverse of the function f of x equals 2x plus 3. So this is the same as y equals 2x plus 3. We're going to go ahead and switch the variables. So every time we see a y, we put an x. And when we see an x, we put a y. And now we want to solve it for y. So go ahead and minus 3. So we have that x minus 3 equals 2y. Divide by 2. Divide by 2. Let's bring it up here. So y equals x minus 3 over 2, or you might see it written as y equals 1/2 of x minus 3. All right, now let's double check them. And when we double check, we should find that, if we take the inverse and we plug in our original function, that we get x. Likewise, if we take our original function and we plug in the inverse, we should get x as well. So let's try one of these. Let's do the inverse first. So we have our inverse, and in place of x, we are plugging in our function. And we solve this, let's see, we see that these 3's here kind of cancel out, right? This is canceled, this is canceled. So we have 1/2 times 2x, which those cancel. So then we're left with x. So that one's good. Let's do the other side now. So here we have the original function, 2, and we're plugging in place of x, we're plugging in f of x. So 1/2 of x minus 3 and plus 3. So let's see, let's kind of simplify this a bit. We see 2 times 1/2 of x minus 3 plus 3, cancels, 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 cancel. We see x. So we're good. Alrighty, example 8, this is our last example from 6.1. We want to find the inverse of the function f of x equals 2x plus 1 over x minus 1. So when we start this, we're going to start it, write it as y equals 2x plus 1 over x minus 1. And then we switch the x and the y. So this y over here becomes an x, and these x's both become a y. Now, to solve this, first thing we want to do is take that y minus 1 on the denominator there. You're going to multiply both sides by that y minus 1. So it cancels it on this side, brings it over on this side. Oops. y minus 1. So on our left side, we have y minus 1 times x. On the right side, we have 2y, that's a y, plus 1. Now, go ahead and distribute that x into both of those terms. I want to bring this up here. So we have xy minus x equals 2y plus 1. At this point, we want to get all the x's or all the y's on the same side. So we'll get the y's on the left. So let's move this x over. Move this x over. So xy equals 2y plus 1 plus x. And move this 2y over. So we have xy minus 2y equals, 1 plus x. Now, from here, actually, let's rewrite that. I don't like that. Let's make this x plus 1. Same thing. All right, from here, we want to factor out something on the left side. So you notice we have, a y in each of these terms. We can factor out a y of both of those. So we factor out a y, we're left with x minus 2. And on the right side, we still have our x plus 1. Guess what we're going to do? We're going to take this x minus 2, and we're going to divide both sides by x minus 2. So on the left side, we only have y left over. On the right side, we have x plus 1 over x minus 2. So this is our inverse function.